Lesson 25, Relations and Functions. The first page here is some different vocabulary for you. You need to make sure that you get this into your notes. The domain is a set of possible values for the independent variable. Those are the input values of a set of ordered pairs. The range is a set of values for the dependent variable, Those are the output values of a set of ordered pairs. And before we go on to the last one, I'm going to talk about a couple things with those two. First of all, the end of both of those, let me get a, whoops, just go ahead and get it done. The end of both of those definitions say of a set of ordered pairs. Okay, both of them do. Let's reflect back on what your knowledge of an ordered pair is. Okay, hopefully you remember that we use ordered pairs to graph, and ordered pairs are always in the form of x, y. Okay, where x is our input and y is our output. Okay, so another name for the domain, or another way to describe the domain, is the input, and that is always our x value. And the same thing goes for range, except for it is our y value. Okay, so make sure that you have that in your notes, because that's something very important to remember. A relation is a set of ordered pairs where each number in the domain is matched to one or more numbers in the range. Okay, a relation is a set of ordered pairs where each number in the domain is matched to one or more numbers in the range. This is what this is saying is that for every x value, it has to have at least one or more y values, okay, for it to be a relation. So give the domain and range of the relation. So they give you this set notation of all of these ordered pairs, and they give you these ovals. And the ovals are a way that I always use to introduce students to functions and relations, because it very quickly tells us or shows us whether we're working with a relation or a function. Things that you need to know about this, first of all, is that each of these are an ordered pair, which means that they are given in the order of x, y, and they want us to give the domain and the range. The domain is the input or the x values. The range is the output or the y values. So, to list the domain, I would show it in set notation, and I'm looking at all of my x values, which are 2, 2, 8, 5, 4, and 3. But I'm not going to list 2 more than once. That would be redundant. There's no need to do that. Once it's there, we know it's part of the domain. And I always just want to show it in numerical order. So 2 comes first, which would get me both of those. Then I have 3, 4, 5, and 8. So I'm going to write those in. 3, 4, 5, and 8. So that's my domain. Knowing that, I want you to pause and try and do the range on your own. So to find the range, we know that the range is the output or the y values. So all we have to do is show in set notation the y values that we have, which would be 6, 10, 6, which we said we don't have to list more than once, 1, 6 again, and 9. So my smallest number there is 1. Then I have 6, which is listed 3 times, but I'm only going to show it once. And then finally I have 9 and then 10. This is the range of my function, or of my relation, excuse me, not my function. What we have with the ovals here is the oval test. This is always, the left oval is always going to be your x values, and if you look over here, we have 2, 3, 4, 5, 8. We have 2, 3, 4, 5, 8. That's always my x values. And on the right side is always my range or my y values, and they have 1, 6, 9, and 10, which is what we have listed for our range as well. Now, what they're showing with these lines is that each input goes to one or more outputs. So 2 has 2 lines coming from it, so we know it has 2 outputs. 3 has 1 line coming from it. 4 has 1 line. 5 has 1 line. 8 has 1 line, which means that they all the inputs meet the requirement of having 1 or more output. A function is a relationship pairing each value in the domain with exactly 1 in the range. Okay, so we're going to use the ovals to determine whether or not this is, or to determine whether this is a function or a relation. So my x, remember, is always in my first oval, my y is in my second oval. So my x, I have 1, 2, 9, 6, 4, and 2, and just like we did in set notation, we're not going to list them more than once if we see them more than once, but we're also going to list them in numerical order. So I have 1, 2, which I have twice, 4, 6, and 9. And my y values, I have 7, 3, 5, 3, 9, 5. So in numerical order, I have 3, which I'm not going to show twice. Then I have 5, which I'm also not going to show twice. Next, I have 7, and finally 9. So what I'm going to do is I'm going to use these ordered pairs to help me make my lines. So 1, the very first one says it goes to 7, so I'm going to go from 1 to 7. 2 goes to 3. 9 goes to 5. 6 goes to 3. 4 goes to 9. And 2 goes to 5. Okay. Wants us to determine whether or not it represents a function. So for it to represent a function, we'll revisit that definition, must have exactly 1 value in the range, which means that there must be exactly 1 line coming from the input to the output oval. So the 1 has 1 line, the 2 has 2 lines. Is that exactly 1? No, it's not. So we would say that no, this is not a function. Wants us to determine whether x equals y squared is a function. For us to do that, we will make our own little t-chart, okay, to determine these things. Whenever we're dealing with a square, it's nice to already be working with square roots, okay, or perfect squares, excuse me, perfect squares. So x, for something to be able to square and get x, I'm going to say that x, if I have, I want 4, that y would have to be 2. Another one would be 9, y would have to be 3. Another one, if I have 16, we have to have 4. We could keep going in this pattern, of course. But I could also get 4 by getting -2, because we should know that -2 times -2 is going to get me that 4, right? And let's see, I could also get 9, I'll extend this here, by taking -3 times -3. So we will use these as our ordered pairs. And we're going to do that oval test to see if it works as a function or not. So my first oval, I'm going to list, I have 4, 9, and 16. And in my second oval, I have -2, I've got to go in order, -3, 2, 3, and 4. So I know that 4 goes with 2 and -2, that 9 goes with -3 and 3, and that 16 goes with 4. Well, once I have this, do I have each input value having exactly 1 output value? Well, the 4 and the 9 both have 2 output values, which means no, it's not a function. Is it a relation? Yes, because they each go to at least 1 or more, but because they have 2 of them, or even just 1 of them that has more than 1 output, that makes it not a function. We can also use the vertical line test. A graph on the coordinate plane represents a function if any vertical line, remember vertical is up and down, intersects the graph in exactly one point. So they show us two graphs here. We have this one with the vertical line going right through there, and when it does that, I have 2 points that it hits, which means it's not a function. On this one though, when I drop a vertical line, it hits just the one time, which makes it a function. So as use the table and the graph to the ordered pairs. Use the table and graph to the ordered pairs on the coordinate grid and determine whether they represent a function. So we're going to use the table to graph them on this coordinate grid. My first point is 3, -4, so I'm going to go 3 to the right, down 4, right there. Next point is -2, so I'm going to go left 2 and up 1. Next point is 4, 3, I'm going to go right 4, up 3. Next point is right 1, up 0, so I'm just going to stay right there. Next point is left 4, up 1.5, right there. And our last point is left 2, down 3. Now we want to know if this is a function or not. We can determine this by using the vertical line test. So I'm going to make my points a little bit darker in each of these that I've graphed already using the table. Remember, that's where we got all these points from, was the ordered pairs that were listed on the table. And I'm going to change the color of my pen to green. If I drop a vertical line, it only hits once. Pretend it actually looks like it hit there. If I drop a vertical line here, pretend it's actually straight, excuse me. Okay, how many times does it hit there? I have 1 and 2, which means that it is not a function. Okay, because the vertical line test fails. Dependent variable y is a function of the independent variable x, so we can write that y equals f of x. F of x and y mean the exact same thing, so whenever we ask to write something in function notation, all they're saying is that instead of y, we're going to say f of x, or whatever the other variable is. If it's d, we would say f of d. Okay, so for example, they have that y equals 6x plus 3. This is the exact same thing as saying f of x equals 6x plus 3. So on example 4, it says to write x plus 4y in function form. That means that I, first of all, need to get y by itself. So I'm going to subtract x from both sides. Whoops, not there. Both sides of the equal sign. So I have 4y equals, these are not like terms, remember, so I have -x plus 7. And finally, I'm going to divide 4 on both sides. So whenever I do this, I'm going to bring it up here. I have y equals, and this was a -1 divided by 4, so I have -1/4 x plus that 7 over 4. But I don't want y equals, I want it in function form, which means I want f of x equals -1/4 x plus 7/4. This is all it takes for us to convert it to function form. On V, it says the mass in kilograms is related to the weight in pounds. There are 2.2 pounds per kilogram. Write a rule in function notation to represent the weight in pounds of a dog whose mass is x kilograms. Well, if the dog is 1 kilogram, it would be 2.2 pounds. If it was 2 kilograms, it would be 4.4 pounds, and we're getting that by multiplying. So they want us to write it in function notation, so we're going to write f of x because we're talking about x as our variable. And we said we could get it by multiplying 2.2 times the number of kilograms, so it's going to be f of x equals 2.2 x. Final answer. I would like for you to pause right here and try and figure this one out on your own. I hope that you've taken good notes and that you have a good night. I'll see you in class tomorrow.